We're going to spend a lot of time using the normal curve, and particularly the area under the curve. Now, that's a bit tricky because the normal curve is, well, a curve. So there's no simple equation for calculating the area under the curve. You have to start with the formula for the normal curve and then use some calculus to calculate the integral across the range of z-scores you're interested in. So we start with the formula for the normal curve. Here we are. All you need to do is every time you want the area under the normal curve, you just take this equation, plug in the scores you have, and calculate the integral for that range of scores. All right? Of course not. We're not going to do that. But it does create a problem. How do you get the area under the curve? Well, the old 20th century approach was to include a table at the back of your book with different z-score values and the area between a z of 0 and that z-score or something like that. And then you had to manipulate that number from the table so that it reflected the area that you wanted. Now, you can do that if you want, but that is like so 1990s, maybe even 1980s. Plus, looking up a z-score in a long table, finding some value, and then manipulating that number to get what you really want is ripe for error. Too often I've seen students who accurately tell me exactly what area under the normal curve they need to know, but then they accidentally look at the wrong row, or they look at the wrong column, or they get the correct value out of the table and then manipulate it in the wrong way when trying to get the answer they need. And it's painful because I'm like, I know you know what you're trying to do, but you're making mistakes that really have nothing to do with your fundamental understanding of the material. Ouch! So I've created a Google Sheet called Z-Score Magic. What I like about it is it's not a 1990s solution. It gives you the exact value for what you're looking for. Okay? Let's take a look. So here I've opened Z-Score Magic in my browser. And the first thing you may notice is that there's two tabs in the file. There's a tab Z-Score to Area and Area to Z-Score. The Z-Score to Area tab is for situations where you know the Z-score and you're trying to determine what's the corresponding area associated with that Z-score. The Area to Z-Score tab is the flip of that. You know an area and you've got to figure out what z-score gives you that area. So let's start with the Z-Score to Area tab. Okay? At the start, at the top, notice it gives us the instructions, just kind of describing how the system works, right? Then we have enter a z-score in a yellow box. That's just where you type in the z-score that you're looking for, that you're looking for an answer for. Okay? Then we have 4 different answers under that, and those 4 answers relate to the 4 types of questions that we discuss in the Magic Words video, right? So you enter your z-score up here, and then based on the specific nature of the question you're asking, one of these will be the answer that you need. All right? So notice I've already started. I put in a z-score of 1.6449. And we've got our 4 different answers for that. Let's start at the bottom here. The area between a plus and minus z-score of 1.6449. Notice it's told us in blue, kind of the red letters in the blue is your answer. It's told us there that the area between a plus and minus z of 1.6449 is 0.90. Well, that makes sense, right? If you've watched the the Z to remember video, you know that's the Z-score that bounds 90%. We know the area between a Z of plus and minus 1.6449 is 0.9. So this is just telling us that. So it's showing it works. Then notice, so again, that's the answer in that blue column with the red letters. Then notice it's actually even got a little picture showing you kind of what's the area, what are we looking at? Notice it's that bounded area. Now those aren't dynamic pictures. Google's not that sophisticated. It's just kind of a static picture, but it still gives you kind of what that looks like for the distribution. Okay, so you can think, yes, that's what I wanted for. I'm looking for that bounded area. All right. Then the next one up is the area that's more extreme than a Z-score of 1.6449. Remember, again, going back to the magic words video, more extreme is the two tails. So we want the area in the two tails, and we know if 90% is bounded between 1.6449 and negative 1.6449, 10% is more extreme than that. And that's exactly what we see for our answer. More extreme than a 1.6449 in both tails is 0.1, 10%. Right? And again, the image shows us exactly what we're talking about, just to help you remember. Yes, that's what I wanted. I wanted the two tails. That's what this answer is giving you. Then we'll move up one more, the area above a Z-score of 1.6449. And again, thinking back to the Z to remember video, we talked about if 90% is between plus and minus 1.6449, that remaining 10% is split in each tail, 5% in the upper tail, 5% in the lower tail. And that's what we see here. The area above a Z of 1.6449 is 0.05. So it's given us the answer that we expect to see. Then notice in this case the figure, there's two figures, and that's just to remind you that we're talking about the upper tail. And it doesn't matter if Z is greater than, the first one is if Z is greater than 0, it's showing, yeah, that little area might be a little sliver of Z greater than, when Z is greater than 0. But we also have if Z is less than 0 to remind you, if this was a negative value, it's still, this answer is everything from that Z-score up to positive infinity, whatever that Z-score is. So it's just, again, a cue to remind you, are you looking at the correct area for your question? A Z, the area above a Z of 1.6449. Then kind of working top to bottom to top, the last one is the area below a Z-score of 1.649. Now notice, it's a positive. We entered a positive 1.6449. You could enter negative Z's, it'll still work. But we're looking at the area below a positive 1.6449. And Z-score magic tells us that's 0.95, 95%. Which makes sense, right? If 5% is above a Z of 1.6449, 95% is below. And again, looking at the figures, it kind of illustrates that for us. It's Z is greater than 0. It's all of that area below a Z of 1.6449. All you need to do then, you can plug in any values. Let's do 1.96. Right, that's another one of our Z's to remember. And sure enough, look, the number's changed, but it's still giving us what we expect. A Z of plus, the area between a Z of plus and minus 1.96, the area between plus and minus 1.96 is 0.95. Z to remembers, right? The area more extreme is that 5%. If 95 is bound by the 1.96, 5% is more extreme. The area above a Z of 1.96, well, that's half of that 5% that's left over, so it's 2.5% is above the positive 1.96. And if 2.5% are above the 1.96, 97.5%, or the area of 0.975, is below the 1.96. So again, everything's working perfectly, but you can plug in any value. You can plug in 0.663 And there's the areas. The area kind of looking from, we'll stick with bottom to top, the area between plus and minus, the area that's more extreme, the area above that, the area below that. They're all there. So again, you need to know the nature of your question. But once you know, I want the area between, I want the area above, I want the area below. Once you know the area that you're looking for, you don't have to do further manipulation. It gives you the answer for that area. As long as you know the correct area, it gives you the answer. So I think that simplifies things, helps to avoid making silly mistakes just copying numbers out of tables. Now, let's roll over to the area to z. So here's the area to z-score tab. And in this tab, we enter the area, and it gives us 4 different z-scores associated with that area, depending on the specific type of question that we're asking. So at the top, we have the instructions. Then here, around row 9, we enter the area that we're interested in. Now remember, these are areas, they're not percents, so they have to be as a decimal value, right? They have to be less than 1 for this to work. Then we have 4 different answers based on the type of question, going back to the magic words video that we're looking at. Now, I've entered an area of 0.95, and let's kind of see how that works with these different answers, starting at the top. So the first one in this case is the z-score below which the area equals 0.95. And you can see then the little pictures show us what we're talking about, right? If the z-score that gives us the area below which the area is 0.95, right? So that's that from whatever our z-score is all the way down to negative infinity is 1.6449. And if that makes you pause for a moment, remember, that's that 1.6449 is the z-score that bounds 90%. But 5% is above and 5% is below the negative value. So if you take that z-score of 1.6449, between plus and minus 1.6449 is 90%, and then below the 1.6449 is the other is 5%. So you put that all together, below a 1.6449 is 95%. So it worked perfectly. Then the z-score above which the area is 0.95. And again, we've got the little picture showing it's the z-score to positive infinity, is a z-score of negative 1.6449. Well, that's just the flip of that, right? That makes sense. 95% are between negative 1.6449 and positive 1.6449. And then 5% more are beyond the positive 1.6449. So you put the 90 plus that 5%, 95% are above a z-score of negative 1.6449. So that worked. Then let's skip this third one. We'll come back to that in a minute. Go down to the bottom. The plus and minus z-score between which. Now we're looking at that bounded question. What z-score bounds 95% of the distribution? Well, that was one of our z's to remember. And there it is, 1.96. The z-score plus and minus 1.96 bounds 95% of the distribution. Now, the third one that we skipped over, this may confuse you at first because it's like, that's a weird number. The z-score where the area beyond that, beyond the plus and minus values of that z-score is equal to 0.95. And notice the value is pretty small, 0.0627, and that's not one of our z's to remember or anything. So where did that come from? And the key here is to remember, what are we talking about? We're looking at an area of 0.95. That's almost the entire distribution. And we're asking the plus and minus z-scores beyond which are 95%. You kind of see it illustrated in the little picture to the right that's got the 2 tails in blue, right? What z-score beyond which is 95% of the distribution. That's almost everything. So it's a z-score really close to 0 because there's only 5% that's in between those two, between plus and minus 0.0627. It's only 5%. That's why it may kind of surprise you until you think about it. Oh yes, it's the area beyond which is 95%. That's almost everything. So again, it's going to be close to 0. We can flip that around by, let's just change our value here. And now we'll say let's, instead of making this 0.95, let's make it 0.05. And now look what happens here. The z-score for an extreme 5%, right? The area that beyond which the plus and minus values is 5% is 1.96. That's what we, right? That's our z to remember. 1.96, 95% are bound by that. 5% are more extreme. So it's all working fine. You just enter the area. You need to kind of go into it. I think, before you even do this, kind of go into it thinking, am I looking above my z-score, below my do I need the area do I need the area above whatever z-score I get, the area below, the area between, the area more extreme? So you know which of these answers you're looking for. You just plug in the area and it's going to give you the right answer, the right z-score. Okay? Now, you may wonder what happens if you do, let's say, remember these are areas, so the area can't be negative, and in fact it can't be 0 because that would be nothing, no area at all, so it'll choke if you do that. Same with it can't be 1. It's got to be greater than 0 and less than 1, or else you run into infinities and stuff. So we can actually see it'll give you an error, so that saves you. Let's I'm going to plug in a z of negative not a z, I'm going to plug in an area of negative 0.8. And what happens? It gives me, notice it gives me an error, number, all these errors. The z, ignore, well, it's giving you errors. This one actually kind of works, but don't worry why. If you think about it, you might see kind of computationally why it gave me a value. But the key is up here. The area must be greater than 0 and less than 1. So it's just telling you, no, in nice big red letters, you've made a mistake. And then if I do something 0.2, let's say I do 2.6, I pull up the wrong tab, and maybe 2.6 was my z-score, and I've gone to the wrong tab, and it's, something's happened. Now it says again, things didn't work, and in red it's pointing out the area must be greater than 0 or less than 1. So it's again giving me an error. So if you see that error, you've done something wrong, right? Okay, so that's z-score magic, all right? Now, you don't have to use z-score magic or other similar digital tables that I've created for other distributions we'll use later on. You can use the tables from our text, or you can use a calculator or Excel. That's great too. But it's one more tool you have at your disposal that I think can help you translate your understanding of z-scores and area under the normal curve to the correct answer to the question. Okay? Bye for now.